Hello, today we are going to see the most important topic in strength of materials, that is shear force diagram and bending moment diagram. First, what is meant by shear force? What is meant by shear force? It is the algebraic sum of all the vertical forces. It is the algebraic sum of all the vertical forces to the right of the section or to the left of the section. That is called as shear force. That is called as shear force. And what is meant by shear force diagram? The diagram which shows the variation of shear forces along the length of the beam. Along the length of the beam. That is called as shear force diagram. For example, the cantilever beam is there. If we draw the shear force diagram for that, it will give this type of nature. This is called as shear force diagram. Okay. Next point is bending moment. Bending moment is nothing but it is the algebraic sum of all the moments. It is the algebraic sum of all the moments to the right of the section or to the left of the section. That is called as bending moment. And bending moment diagram, which is nothing but if we consider a cantilever having point load at free end, the bending moment diagram which shows the variation of the moments along the length of the beam, which gives us the result as this one. This is called as bending moment diagram. These 2 points are important. What is meant by shear force diagram and what is meant by bending moment diagram. Shear force diagram is nothing but the diagram which shows the variation of shear forces, all the vertical forces along the length of the beam to the right or to the left of the section. And bending moment diagram is nothing but the diagram which shows the variation of the bending moments, force into perpendicular distance along the length of the beam. That is called as bending moment diagram. Okay. The next point is types of leaves. Next point is types of leaves. Okay. The first type is cantilever beam. It is represented by this. This is called as cantilever beam having length L. Second is simply supported beam. Simply supported beam. It is represented by this. Okay, having length L. Third one is continuous beam. Continuous beam. It is represented by this. Means number of supports are there. This is called as continuous beam. Fourth one is overhanging beam. Fourth one is overhanging beam, which is nothing but this is the overhanging portion. That's why it is called as overhanging beam. And last one is fixed beam. Fixed beam. In this, the beam is fixed between the two fixed supports or walls. That is called as fixed beam. These are the 5 types of beam. Okay. The next point is types of loads. Types of loads. First one is point load, or we can say it as concentrated load. Concentrated load. It is shown by a dot or simply one arrow mark, vertical arrow mark is there. Second is uniformly distributed load. Uniformly distributed load. It is shown by like this. If we consider length L over which, yes, W weight is acting Newton per meter, W Newton per meter. It is for solving the SFD and BMD, we have to convert this UDL into point load. How to convert this? Simply we can take a load at L by 2, okay, and the value of force is nothing but W into L, the UDL into length, W into L, which is acting L by 2 from left hand, L by 2 from right hand. This is very important because while solving problems, in every problem where UDL is given, we have to convert it into point load. Okay. Third point is uniformly varying load. In that, if we consider this beam, this load is given like this. Okay. And this is nothing but W Newton per meter, and this is length, this is W. Okay, we have to convert it into point load. How to convert it into point load? For that purpose, we are going to draw one line, and here 2L by 3 from point load and L by 3 from this base, L by 3 from base. This is the standard nomenclature, and the value of force is nothing but area of the triangle, 1/2 base into height. Here our base is L and height is W. This is the point force. This is also very important while solving the examples. Okay, these are the types of loads and how to convert this UDL into point load, where is the distance, and how to convert this UVL into point load and where it is acting. Clear? Understood? Okay. The next point is sign conventions. The next point is sign conventions. Okay, sign conventions for shear force diagram. How to remember this sign convention? In book it is given as like this. Okay, how to remember? We can say run means right upward negative, means right upward negative, means to the right of the section the force which are going towards upper side, that is negative, and opposite to that the force which is going towards down, that is positive. Only this we can remember for further processing, and this sign convention is opposite to this. This is sign conventions for shear force diagram, and sign conventions for bending moment diagram is like this. This is positive, and this is negative, this is also negative. How to remember this? nowadays we are using WhatsApps, Facebook and a number of social medias. In that we are using smileys. Okay, we can convert it into smileys. Okay, this is smiling face, uh, this is smiling face. हा नाराज आहे. ओके, तर रिसेंटली 14 फेब्रुवारी पण झालेला आहे. तर हा काय झाला आहे, खुश आहे. म्हणजे हा काय, याला काय तर आन्सर पॉझिटिव्ह आलेला असणार आहे, याला आन्सर निगेटिव्ह आलेला असल्यामुळे तो काय नाराज आहे. त्याच्यामुळे काय करायचं आहे आपल्याला, साइन कन्व्हेन्शन्स लक्षात ठेवायचे आहेत. हा पॉझिटिव्ह आहे म्हणून हसायला आहे, हा नाराज आहे म्हणून काय केलं, नाराज आहे म्हणजे आपण चेहरा पाडून बसलेला आहे. ओके, तर हे काय साइन कन्व्हेन्शन्स निगेटिव्ह आहेत. ओके, तर राईट साईडला वर जाणारा कपल काय असणार आहे, पॉझिटिव्ह असणार आहे. लेफ्ट साईडला वर जाणारा कपल काय असणार आहे, पॉझिटिव्ह असणार आहे. सिमिलरली इकडं राईट साईडला खाली येणारा कपल निगेटिव्ह आहे, इकडं निगेटिव्ह आहे. ओके, तर या पद्धतीने आपण हे साइन कन्व्हेन्शन्स लक्षात ठेवायचे आहेत. आणि ह्याला आपण म्हणतोय सॅगिंग बेंडिंग मुवमेंट, आणि ह्याला म्हणतोय आपण फॉगिंग बेंडिंग मुवमेंट. ह्याला काय म्हणतोय, फॉगिंग बेंडिंग मुवमेंट. हे सायन्स कन्व्हेन्शन्स खूप इम्पॉर्टंट आहेत या चॅप्टरचे एक्झाम्पल सॉल्व्ह करण्यासाठी. थँक्यू.